Welcome back to the deep dive. I want to start today by asking you to uh, just look at your computer screen. I mean, really look at it.
Okay.
What do you see? Do you see a tool that does exactly what you command it to do?
hmm
Or do you see a collection of, colorful icons and menus that someone else decided you should have?
That is a very philosophical way to start a Tuesday. But, it's the right question.
Right.
Most of us, even people who think they're pretty tech savvy, we're basically just guests in our own operating systems.
We stay in the lobby.
We do. We use the apps. We click the buttons they give us. We stay within the guardrails.
Yeah, we are passive observers of our own data. We look at spreadsheets. We stare at dashboards.
hmm
But we're just looking. Today, I want to flip that script.
Hmm.
I want to talk about taking control, moving from the lobby, into the engine room.
And the key to that engine room, the master key, really, is the command line.
The dreaded black screen.
It is intimidating. It's that blinking cursor on a dark background. It feels so archaic.
Like you're hacking a mainframe in a movie from 1985.
Exactly. But practically speaking, the command line is a superpower. It lets you interact with data with a level of precision and automation that just pointing and clicking can't match.
So today is a very practical deep dive. We're looking at a technical guide called SQLite Commands.
Right.
And our mission is, well, it's simple, but it's ambitious. We are going to walk through, step by step, how to install and run SQLite.
Which is the most widely used database engine in the world, by the way.
And we're going to use it to play around with this really cool test data set called the Chinook database.
And this guide is great because it doesn't just give you theory, it covers the nuts and bolts, the installation, the tools, the exact commands you need.
We are going to demystify the setup process,
Mm-hmm.
which, let's be real, is usually the part where people just rage quit.
Oh, it's the biggest barrier to entry. If you can get past the setup, the actual interaction is often the easy part.
So by the end of this, you won't just have software installed. You'll be ready to query a digital media store using raw SQL commands. So let's get equipped. Where do we start?
We start at the source. The first step is getting the binary files. You
No.
need to go to the official download page, which is SQLite.org, download.html.
Okay, that seems straightforward enough.
Right.
But looking at the source here, usually when you download software, you're looking for a big, shiny download installer button.
Yes. You want a little wizard to pop up?
A .exe or a .pkg file that does a little dance and sets everything up for you.
And if you go to that page looking for that experience, you will be confused. That's like the first mental hurdle. This is not an installer wizard.
You're downloading the raw binary files.
Exactly.
Let's pause on that word binaries. For someone who just uses Excel or a web browser, that sounds a bit intense. What are we actually downloading?
Think of it like buying a high-end power drill. You don't need a drill installer wizard to build a shed for the drill to live in. You just need the tool itself. The binary is the tool. It's the executable program that does the work.
So if I'm on Windows, what am I looking for specifically?
The guide, it specifically mentions the Windows example file. SQLite tools Win32 by 86342000.zip. Now, don't get hung up on the numbers at the end. Those will change.
Right, versions.
But you want that tools zip file.
Okay, so I download this zip file, and here's where it gets interesting or maybe confusing for people. I shouldn't just leave it in my downloads folder to die, should I?
Please don't. That is a recipe for disaster. You need to unzip or extract those files to a folder of your choice, but you need to be organized about it.
The source suggests a specific spot for this, right? To keep things tidy. It says, users your name SQLite tools.
Which is a good convention. It keeps it accessible but out of the way. But, and this is the most important part of the setup, simply putting the files there is not enough.
Right, because if I just unzip them and try to run a command, my computer's just going to stare at me blankly.
Exactly. You've bought the drill and you've put it in a drawer in the basement. But when you shout drill from the living room, nothing happens.
This brings us to the crucial step, the path variables.
Precisely. This is the number one stumbling block. You have to tell your computer, hey, when I type SQLite 3, look in this specific folder. You have to add that path to your system environment variables.
I feel like environment variables is a phrase that makes non-technical people start sweating. It sounds like something deep in the system you're not supposed to touch.
It can be intimidating, but let's use an analogy. Imagine your computer has a very strict receptionist.
Okay.
When you type a command like SQLite 3, you're basically shouting a request at this receptionist, get me SQLite 3.
Right.
And the receptionist has a list, a very short list of places they're allowed to look. If see users use SQLite tools isn't on that list, the receptionist just shrugs and says, I don't know what that is.
So setting the path variable is basically writing that new folder location onto the receptionist list.
Exactly. You are authorizing the system to look in that folder.
And the source material is really helpful here because the steps are different for Mac and for Windows.
Right. It explicitly links to a guide on Help Desk Geek for Windows users on how to do that. And for Mac or Linux users, it points to a CyberCity FAQ.
So if I skip this step, what happens then?
You'll get the exact error message mentioned in the source. SQLite 3 not found. Your computer literally doesn't know the tool exists because you haven't introduced them yet.
Okay, a very polite way of putting it. So you have to do the introductions. Now, before we jump into the command line, the source does offer an olive branch to people who just cannot deal with the black screen.
Yes, it mentions GUI DB tools. GUI stands for Graphical User Interface. The source suggests downloading dbeaver Community.
Which sounds like a very industrious piece of software.
It is. It's a visual tool where you can, click on tables and see data in a grid. It feels very familiar, almost like Excel. But today we are choosing the powerful path. We are sticking to the command line. dbeaver is great for viewing, but if you want to understand how databases work, or if you want to automate things later, you really need the command line.
Okay, so we've got the tools, we've set our path variables. Now we need something to play with. We need data.
A database engine without a database is like a Ferrari without gas. Looks nice, doesn't go anywhere. So we need a data set. And the source introduces us to the Chinook database.
I love this concept, a sample database. So describe what we're looking at here. What is Chinook?
So the Chinook database represents a digital media store. Think of it like a simplified iTunes or a digital record shop from the mid-2000s.
Okay, so we're not looking at boring abstract data like item A and value B.
No, not at all. It's relatable. It's got tables for artists, albums, media tracks, invoices, customers. It's designed to simulate real-world business data.
And why does that matter for someone who's just learning this?
Because it provides context.
Yeah.
If I tell you table A is linked to table B, your eyes glaze over. But if I say, we need to find out which customer bought the most tracks from AC/DC, suddenly you understand why the tables need to be linked. You can actually visualize the question.
And the source says you can find this chinook.sqlite file in the intro database repository or download it from sqlitetutorial.net.
And it's a sandbox. That is so crucial.
That's sandbox.
It lets you test, break things, experiment without the fear of, deleting your company's actual payroll data.
Right.
You can drop tables, delete invoices. You can mess it up completely. It doesn't matter.
Which is generally frowned upon in a production environment.
Highly discouraged. Keep your experiments in the sandbox.
Okay, let's enter the matrix. I'm opening the CLI. On my Mac, it's terminal. On Windows, it's command prompt.
The anticipation is building.
I'm staring at the prompt. What's the magic word?
The command is just SQLite 3. Simple as that. If you set your path variables correctly, you type that, hit enter, and you'll drop right into the SQLite shell.
Okay, but right now I'm just in the engine. I'm not connected to the record store yet, am I?
Correct. You've opened the application, but you haven't opened a file. This is where that open command comes in. But, and this is a big but, there is a trap here.
There is always a trap.
You can't just type .openchinook.db. Well, you can, but unless you're in the exact same folder as the file, SQLite will actually create a new empty blank database with that name.
So you think you've opened the store, but you've actually just opened an empty room.
And you'll type, show me the tables, and it shows you nothing, and you'll think you're going crazy.
So what's the best practice here to avoid the empty room scenario?
The source emphasizes providing the absolute path to the file.
Walk us through that. What does that mean?
So instead of just saying open the file, you are saying open the file located at users my name downloads chinook.db. You're giving the full specific address.
Got it.
This makes sure that no matter where you're running the command from, SQLite finds the right file.
Okay. I've typed .open and the full path to my Chinook file. I hit enter and nothing happens. No fireworks.
In the Unix philosophy, no news is good news. If it didn't give you an error, you are in. You are connected to the Chinook digital media store.
So I'm inside the store, but it's dark. How do I look around?
This is where we start using the dot commands. These are special commands in SQLite that start with a period, and the very first one you always use is .tables.
Tables. Simple. And that just lists everything.
It lists every single table in the database. It's like looking at the directory map at the entrance of a mall. You'll see albums, artists, customers, and so on.
Okay, so I see albums, But I don't know what kind of information is in there. Is it just the name, release date?
Exactly. To see the blueprint of a specific table, you use the .schema command. So you would type schema albums.
Schema. I like that word. It sounds like scheme.
It comes from the same root. It shows you the structure, the actual create table statement that built it. It'll tell you the albums table has an album, a title, and an artisted.
Wait, artisted, not the artist's name.
No, and that is the beauty of a relational database. It just has the ID number. If you want the name, you have to go look it up in the artist's table. It's about efficiency.
Okay, that makes sense.
You don't want to type Led Zeppelin 100 times, you just type the ID number 1 100 times.
So tables gives me the list of containers, and schema lets me look inside a container to see how it's organized.
Precisely, it gives you the blueprint.
Now, the source material brings up a clever use case. Imagine this database is huge, thousands of tables. I don't want to see a list of 1,000 names.
Yeah, you need pattern matching. This is incredibly useful. The guide gives the example of finding all tables that end in "-ese.
Like plurals,
Yeah.
employees, genres.
Often, yeah. The command is .table%.
And that percent sign is the important part.
The percent sign is a wild card. It stands for anything. So %ents means anything that ends with "-ese.
So if I run that in Chinook, what do I get?
You would get employees, genres, invoices, playlists. It filters out all the noise.
That's a great trick. Now, there's another command mentioned here, indexes.
Ah, indexes.
Without getting too deep into database theory, what are we looking at here?
Think of an index like the index at the back of a textbook. If you want to find George Washington, you don't read every single page.
Right, you just jump to the back.
You go to the index, find the page number, and you jump right there. Databases use indexes to speed up searching.
And we can see these hidden structures.
Yep. You can type .indexes albums to see the indexes on the albums table, or you can use that same pattern matching trick, .indexes%.
And the source notes that quotes are optional there.
It does. Yeah, the SQLite shell is often pretty forgiving with quotes for these things.
Okay, so we've installed, we've connected, we've looked around. Now for some advanced moves. The source has a section on output.
This is a feature that makes the command line so powerful for automation.
Usually when I run a query, say, select all album titles, the results just scroll up my screen and then disappear.
Which is fine for a quick check, but what if you need to send that list to your boss? Or import it into another program? You don't want to be copy-pasting from a terminal window.
It's messy.
So the command is output file name.
So .outputalbums.txt.
Right. And once you type that and hit enter, something interesting happens.
What's that?
Nothing.
The screen just goes silent.
Yep. Because you've just told SQLite, don't show me the results. Instead, point the hose somewhere else, write everything to a file named albums.txt.
So if I then run my SQL query select title from albums, I won't see the list.
You won't see it on the console, but in your folder, a new file called albums.txt will magically appear, and it'll have that entire list in it.
That is incredibly cool. It's like teleporting the data.
It is. And to get back to normal, to seeing things on your screen, you just type .output with no file name. That resets it.
Okay, one last advanced move.
Yeah.
This one feels like real programming, scripting.
This is where you go from being a casual user to a power user. This is automation.
So the scenario is, I have a bunch of commands I run every Monday morning. Maybe I'm generating a report. I don't want to type those commands out manually every single week.
And you shouldn't. Human error is real. You'll make a typo, you'll forget a step. So the source suggests creating a file, let's call it commands.sql.
And I just write my SQL queries in there.
You write all your queries in that text file. It's like a recipe.
A recipe, I like that.
Then, from inside SQLite, you just use the command.readcommands.sql.
And it just does everything in the file.
It executes every single statement in that file, top to bottom, instantly.
Wow, that is efficiency.
It allows for really complex workflows. You could have a script that sets the output to a file, runs a huge query, resets the output, and then prints done to the screen, all with one command, .read.
It really connects back to what we started with, taking control. We aren't just clicking buttons someone else designed for us.
We're building the machinery. We've gone from downloading a zip file to building automated data extraction scripts.
Let's just recap this journey, because we covered a lot of ground pretty fast.
We did. We started with the installation, downloading those binaries, and unzipping them manually.
We conquered the dreaded path variable, so our computer actually knows where SQLite 3 lives.
Yep.
We downloaded the Chinook database, our digital record store sandbox, so we had safe data to play with.
We learned to launch the tool with SQLite 3 and connect using .open with an absolute path to avoid that empty database trap.
We navigated the structure using .tables and .schema, and used pattern matching with the % to filter our view. And finally, we learned to export data to text files using .output and automate the whole thing with .read.
It's a complete toolkit for basic database interaction.
And honestly, these skills, CLI navigation, understanding file paths, batch processing, these apply way beyond just SQLite.
Oh, absolutely. If you can handle this, you can handle Python scripts, you can handle server administration, cloud computing. This is foundational technical literacy,
It's about understanding how the computer actually works.
not just how the interface looks.
So here's my question for you, the listener. We've been playing in the Chinook database, looking at fake invoices and artists. But you have real data in your life. You have bank statements, fitness logs, maybe a huge spreadsheet of client contacts you've been dreading opening.
Data that is currently trapped in static rows and columns.
Exactly. So now that you know you can unlock this power, what personal data do you have trapped in spreadsheets that could be unlocked if you treated it like the Chinook database? What could you find if you could really query your own life?
That is a fascinating thought. If you can ask the question, the data can usually give you the answer. You need to know how to ask.
Something to chew on. Thanks for diving in with us.
Until next time.